Now, besides that, the y-intercept. Well, the fast way to find the y-intercept is to set x equal to 0. That means go back, replace x by 0, and you end up with, we'll call this y here, y is equal to a negative square root. If I set that x equals 0, it merely end up with a 4 plus 3. See if you guys agree. Replacing x by 0. Which gives me y is equal to, looks like negative 2 plus 3. Looks like a 1, and I like ordered pairs for points, so let's call that 0, 1. There's my y-intercept. I'm going to take a close look, and then I'll put these items on the grid and get the graph finished. So I now know the y-intercept, I know the x-intercept. So guys, let's get that done. I'm putting it in black here. In fact, I already have a point here to work with. That's where that vertical shift up 3. But now I have negative 5, 0. That's interesting. Over here at negative 5. Right here. The graph's going to cross over. Y-intercept at 1. And this point. Is that enough to get the graph? Does my last graph, by the way, it's got to resemble this. Is my last graph with a little curve to it? I'm going to do something like that. Maybe smoother than what I have mine. Is it going to look something like that? Start here, go through the y-axis, go through the x-axis. Notice I made it cross over the x-axis at negative 5. And there's, in the black, is a picture of, a graph of this. That was the hardest thing for me in grad school. And they thought by the time you get to grad school, Ramsey, you should know if you see this in your mind. It took me a little time to do it though. In your mind, without graphing on a board or paper, you should know it looks like this. I thought, oh, I should. Everybody just walks around. They know that black function over there. That's its picture. No, I didn't know. I could graph it, but they thought, no, you should know that. It should be in your head right now. Yes?
You said this will be on next week's quiz.
That's going to be on your quiz, your next quiz.
Yes. Do we need to show every transformation?
Well, absolutely. Absolutely. It might be nice to find some colored pencils or something. Okay, guys, because I give you partial credit for each transformation. Each transformation counts a little bit. Okay, let's step to the side, guys. Do you agree? Yes.
For all quizzes, do you want us to do it graphically, or can we, like, if we know what the, like, essential, like, the most important parts of, like, the paragraph are, can we show the transformation?
I know how my quiz is going to be labeled. It's going to be saying use transformations, or no, it's going to say show each transformation. So you've got to show each one, like I did here. Okay? My quizzes are what, 10 points? So by the time you have your next quiz, I think what, next Wednesday, I think there's a quiz 3. It's going to be something like this. And probably be just one problem. For 10 points. Just show me the transformations. Now, let's do a little bit with it. We're done with it. Got the graph. Let me go back to this. Can anyone tell me, without the graph, I know the graph, without the graph at all, just the original black function, can anyone tell me that function's domain? What am I allowed to replace x by? All real numbers, or is there a restriction? I'll tell you right now, you can't let x be a 5. I just randomly chose one. 4 subtract 5 is -1. You can't just do a square root on -1, so there must be a restriction. I think I heard students trying to tell me. Yes?
Minus infinity to 4.
Oh, well, hold on. So you're saying the domain, negative infinity up to 4. Did you want to include 4? Bracket?
I think yeah.
Okay, we'll see. Now, what does he see that maybe we don't see right now? Is he correct? Is he correct?
Yes.
Yeah, what does he see that we don't see? How do you get that answer so fast? He's just one of those super smart guys. How do you get that answer so fast? Now, here's what I would do, and I'm sure in his mind he's probably doing the same thing. You say, wait, Professor, you've shown us before that if you have a square root, no matter where it's located, this part underneath, they call that the radicand. This part underneath must be what for a square root to make sense? In other words, you take the square root, what types of numbers? That part underneath there must be that, or you cannot do a square root on it. Can never be negative. Then what I would do after I realized that, I would solve this inequality, move that 4 over, divide by negative or multiply by negative, reverse my symbol, and I had my domain. Does that agree with what he gave me? He gave it to me in interval notation. Are we saying the same thing? Absolutely. Now, can someone tell me in this class, besides the answer my student gave me, I showed you a process I like myself. Does anyone see another way now to find the domain? I see one more thing you could turn to find the domain. What is it? Shame on you. There's something staring at you from the board that says, oh my goodness, I see the domain has to be negative infinity, Professor, up to 4. Where is it that we have not used it yet to find that same domain? Yes?
Sign analysis?
Maybe that's, no. I think that's sign analysis. Something on the board right now. It's staring at you right down the board. Go for it.
I mean, can't you just tell by the plotted points?
Tell me more.
Well, they're dots instead of an infinite line. So
Oh,
it's
yeah,
just
you're
start.
right there. You're thinking correctly, but we're not going over to UCLA or USC. Now you got to tell me more. You're right around it. Look at the graph. Look at the graph. From left to right.
Oh.
Does this black graph say this goes forever this direction? Which is negative infinity. But in this direction it stops where? 4. Is that the same answer? Is that the same answer just based on the graph? The negative infinity over the 4. You can just look at the graph. So my gosh, I see the extent. Just look at the graph. And it's done. Okay. Now before I leave it, I love this problem. It's a transformation problem. Before I leave it though, everything's done. One more little item here. I've named my function. Here we go. Can anyone tell me where am I guaranteed? Let me describe this for you. Where am I guaranteed that when you replace x by some number in the domain, you gotta use the domain though. You may try any number you wish from a negative infinity up to 4, you put it in there, you do your calculations. Can anyone tell me in what interval, I think of a good way to do this, will the answer always come out to be negative? The answer, not the x necessarily, the answer coming out. Go for it.
Negative infinity to negative 5.
Now, tell the class, what are you looking at there to answer that?
The y-intercept.
Are you, also it says less than 0. Does that mean below the x-axis? So where is my black graph below the x-axis? Let me shade. Let's see if you guys will agree. Is this the piece, it goes forever. Is this the piece here that's below the x-axis? That true? And how would you describe that? From where to where? Is that the little piece of the black graph that is below the x-axis? And that's what this wants you to find. When is the y negative? Now the y's definitely are negative down there. So when are the y's negative? It's when it's below the x-axis. Does anyone see an interval notation? How would you list that? I think you were listing it for me. What would you say?
Negative infinity to negative 5.
Negative infinity over to negative 5. Now, I'm not going to include negative 5. I'll put a parenthesis. Because right at negative 5, it's right on the axis. I'm looking for when is it below. I'm not going to include negative 5. It's right on the axis. Okay? Now, I will just point that out. You know what? I better point out something else. I'm going to close this down here. Anyone tell me, where am I guaranteed that that function over there is going to be positive? Can I tell that from the graph? Now you're looking for the part that's above the x-axis. And guys, that black graph is above the x-axis. And see if you guys will agree. Is this the piece that's all above the x-axis? Now, can anyone venture out and tell me an interval notation? When's that happening? That's above. From what to what? Go for it.
Negative 5 not included to 3 included.
And over to what was it, 4?
3.
I thought it was a 4 here.
Okay. 4, yes.
Yeah, 4.
Sorry to hit the.
And I want parentheses here. Now, someone tell me, someone asked a question the other day when we saw something like this. Could I actually get by with placing a bracket on the 4 in this case? And the 4's not down here on the axis, is it? So if I saw a student say, Professor, in this case, could I actually put a bracket here and include 4? It's not on the axis here like the negative 5 was. You could. I believe like that. But that's what you were talking about, right? Okay. Just based on the graph. Now here it goes. Now we'll close it down. I'll make some sense of this. This transformations are really done here. I'm gonna go back to my function. Here it is. And I'm gonna ask you to please give me a number of your choice caught between negative 5 up to 4. You're gonna give it to me. I'm gonna go over and plug it in to that function. I'm guaranteed, I don't want to embarrass myself, whatever that number is you give me that's in here, I'll go back and put it in. The answer coming out had better be positive. The f of x must be positive, or we've done something wrong here. Can anyone give me a choice of a number caught between, there's an infinite number of numbers. Can you give me one caught between negative 5 and 4? There we go. 2? 2's caught. We'll try 2 here. 2 would look like this. F at 2 is negative square root 4 subtract 2, you have to use a 2 there, plus 3. This becomes the negative radical 2 plus 3. Now, radical 2, I think we all realize radical 2 is 1 point something. So this says negative 1 point something plus 3. If I add those two together, negative 1 point something plus 3, will I get a positive result? And that's what I wanted. Is it true? Is this positive? And you can give me any other number besides 2, caught here, take it back, plug it in, you're guaranteed the answer will be positive. Wow. Let me slow down. I'm going to erase this. Any questions? Any concerns here on this? Yes?
Would you be able to find the range just from what's
Ah, beautiful. Hang on, hang on, hang on. Oh, hang on. Just wait, Professor, you're not finished yet. You gave us, we try to find where it was, you gave us, where on earth did I place the domain? We listed the domain somewhere, we went over here. He said, wait, Professor, don't erase this yet. What's the range on this? The range is the up and down, the y's. Well, if you look at that black graph, guys, I would think, if you agree with me, is it dropping down forever? I know it's going to the left also forever, but is it dropping down forever? Does a negative infinity over 2, be very careful. I'm looking at the range, and I know this point right here is probably what? Was that 4, 3? What's that, guys? I think it's 4, 3. So what would you describe the range as? Negative infinity up to what number? 3. And we'll include 3. Yes? No? Jeez. Nice. Now, that's a complete problem. That will take you, or you will have 10 points. That's a 10-point problem right there. Just it, staring at you. I could even throw more questions in about it than what you see right now. Guys, my transformations are done. I should point out, I wrote myself a note. When my student read all the transformations to us, there was no mention of, hang on, I'm gonna ask you what you think would happen. Suppose there had been, besides the negative sign out front here, let's say there had, was a, let me make a number up right quickly, a 2. Suppose there were a 2 out front besides the negative sign. Can anyone tell me what effect might that 2 have? If it were on the end, it would be a vertical shift, up 2. Does anyone think they know what it would happen if it were out front? What effect would it have on my parent graph then? Yes?
It would shrink it.
You almost said, not shrink. It depends on the number though. In this case, it's a 2. Is it going to stretch? It would stretch the graph. In other words, when you stretch the graph, this parent graph, where on earth was my parent graph back here? That parent graph, oh here it is. That parent graph is going to be stretched up some. It's going to be more like that. For a vertical stretch. By a factor of 2. So that's what that 2 out front might do to the shape of that graph. It might vertically stretch it. If the 2 were inside here somehow, maybe out, where is it, out front here somewhere, what do you think would happen then? In fact, I think we looked at that one. I think they call it, what, CX was it? Was a CX inside? You remember that, guys? Was that like a horizontal shrink or stretch? We looked at that one yesterday. I think it was yesterday. Okay? I just want to make sure you understand how to do a transformation problem. Okay, I'm finished with that. Now, because the professor, where are we now? Well, we are, hang on. Let's see if I am ready for you. Oh my goodness. I've got a handout here. I've condensed the sections for you.